Good morning, everybody, and thanks for being here. Uh, I would like to start off with saying that I'm really happy that we could do this physical conference after 2 years of crappy COVID. So really happy to see you all here then. My name is Rangarajan. I work with Accenture, Netherlands. I'm a Java dev and an architect. I have been working with Java and related technologies for the last 13 years. And yeah, it's fun, and I like what I'm doing right now. I'm here to talk about an exciting thing that I came across last year. It's called as RSocket, and I want to talk about why it was exciting for me, how I see its benefits, and where I think it could help us in our application development and enterprise application development. So what I want to start off with doing is a small problem statement, the reason why I think that we should go in for RSocket, what RSocket offers us, and why it is a solution for us, some features and capabilities which I really think would be useful for us in our day-to-day life and our application scape. Then I do have a code demo which I can walk through, and a Q&A. I also have an exciting news somewhere in the end of the presentation, so be tuned on for that one. The problem statement, yeah. Communication in the cloud. We have a lot of scenarios where we build a lot of applications which talk across 4 network levels, 4 services, 4 microservices talking to each other over network calls, which finally makes a database call or an ERP call or something on the lines. There is no standardized way to achieve this. This standardization is lacking. And when it's there in place, it would be really helpful in managing and simplifying our management of the whole application landscape itself. A lot of our problems that we try to resolve using things like historics or resilience, etc., they come from somewhere on the network level. But since it's a network, none of the application developers like to touch on it. They don't even want to think about it. They say, okay, if we have a problem, I'll solve it on the application layer. I'll bring a fancy API or build up a fancy API, and it will solve all my problems. We are patching in things and hoping that it'll work in the long run. A lot of architectural patterns, especially in the Reactive manifesto or implementations, favor asynchronous and non-blocking messaging patterns, non-blocking behavior, and other messaging patterns which we don't have in HTTP itself. Therein comes in RSocket. It's a networking protocol. What does it do for you over TCP or over HTTP? It brings reactive programming semantics to the network layer. It's in 5-6 layer in the OSI. It's a session and presentation layer. And what it does is it brings a standardized approach to solving all the problems that we can foresee. A lot of the applications that we build have common requirements, right? Flow control, service discovery, load balancing, service resumability and cancellations, and stuff like that, security. RSocket provides a common place where you can really identify, solve it in a structural and nice manner and a consistent manner. You can solve, for example, I'll come to that in the future slides, application backpressure. You can solve it in one place, or you can set it up in one place and have it propagated across a network or multiple API calls. Yeah? So you can have one API which talks to another API, which talks to another API, and talks to a database. You can have this application backpressure implemented all the way through when you set it up in the first place. RSocket is built by, has been defined and built by leading industry pioneers in the cloud application development, like Facebook, Pivotal, Netflix, and Alibaba. And they are the major contributors to this as well. And what it does is that it brings up a nice ecosystem and a nice use case where we can already start seeing early adoptions over there. I want to go over the features and why RSocket might be a good thing for us in the future. HTTP, 99% of the network traffic or the application development that we do works over REST, HTTP. Why? Because we believe HTTP is the best, yeah? We say, whenever you think of, somebody thinks of building an API, a microservice, we say, okay, REST does an API call over HTTP, we are done, yeah? Is that good? HTTP was built for a scenario where you make an web page request to see a bunch of library books. You say, the client says, I want this list of books. The server says, here is an HTML, which gives you the list of books. It's a request response. We, as application developers and architects, we see more use cases than just a request response model, right? RSocket, it's reactive, it's message-driven, it's bidirectional, and it's binary multiplex communication in the whole channel. How does it differ from WebSockets? WebSockets brings you just framing semantics. It doesn't give you application semantics. You have to do that on your own. You don't have a web application protocol. You have to do that on your own in WebSockets. That's the benefit of RSocket. It gives you the whole flow. Server-side, server-sent events, or SSEs. It was built as it was introduced as an add-on to fix the backdraws or drawbacks of HTTP. Okay, fine. The code is pretty simple. It's very similar to HTTP in the sense it's mostly similar to HTTP, but it doesn't have any backpressure. It doesn't have any flow control and no way to use a compact or a low overhead encoding on top of it. RSocket gives you much better performance. It gives you so many options to tune for higher performance as it was defined for efficiency and transparency. It emits backpressure between the clients and the multiple layers of network communication that happen, I was talking about earlier. Interaction models. And this is something that was really fun for me when I encountered this, yeah? So last year, I was working on something for one of my projects, and I came across a scenario where I said, it would be nice to have, I just need to make an API call. I really don't care about whether it goes through, what's the response that I get. I just need it to be completely asynchronous and non-blocking. That's why I came across RSocket in the first place, and that's why it got me all interested. So RSocket gives you 4 interaction models, yeah? The fire and forget. As I said before, you make an API call or make a request, and then forget about it. You don't get any acknowledgement that that it was received, any action was taken. You don't need it. It's perfect for situations where you can tolerate a certain amount of loosiness. For example, sending 100 million events to Splunk or one of the logging frameworks. Yeah. So if a line of log gets lost here and there, do we really care about it? Not so much. So it's really perfect for that. It helps you. I'm sorry. It helps the client in not expecting network acknowledgement or a request acknowledgement and then move ahead and do its own stuff. Request response. HTTP is so widely used because it supports request response, right? We see a lot of traffic on HTTP for request responses. We still think that it'll be the same case in the future as well. RSocket supports this. I'm sorry. RSocket supports this, and it does it in a better way. It makes it completely asynchronous and non-blocking. You do not have to wait for a response and block network or block the resources. It comes in when it comes in. You just act on it using you just act on it using callbacks. Request stream. This is a nice use case where you have you send a request over to the server, and you get a series of responses in back in return. One use case could be that you say, give me an account number, and I want to return back all the transactions for this account number. It happens, right? So it's quite fun. Channel, or what is also called as a stream model. This is where you send in a series of requests over over to the server as a request, and then you get a series of responses back. It's nice in the sense it's built in completely for an interactive conversation or an interactive behavior. It's built for interaction. Consider a use case where you say, I'm a customer, I'm browsing through all my accounts. Yeah, I see an account number, I like it, and I want to go into see the more transaction details. It goes through. The server sends you back a series of responses in terms of transactions. You put in a filter saying, okay, I want to see only the transaction for this specific type. You send a request again, or it's in the same channel. You see it's as an additional filter. The server just responds you back with the new set of transactions, right? Application flow control. I spoke about this like 4 slides back. The backpressure concept is embedded into RSocket. The flow control. What is backpressure? I'm sorry. Let's start with that. Around 10, 11 years ago, I used to work in an application where we were requesting all the data for a customer. Yeah, we suddenly saw that the database was sending us back like 100,000 records, and the application, of course, crashed. You can restrict this. The client can now say, hey, I want data, but I want only 2 messages. And I repeat this, yeah? I want just 2 messages. I don't want so many bytes. I want messages. So you can define application backpressure in terms of messages, which is more understandable for us developers. 500 kilobytes of messages, how many messages is that going to be? It's a bit abstract, right? So the backpressure, you have the server, the client, which says, I want 2 messages. So send me data in batches of 2. The server responds back with 2 messages. It's accepted. If it sends in back 3, the network protocol implicitly says, hey, we have a problem. The client said 2, you're sending in 3. We are not going to take that, yeah? So it gets rejected. The nice thing about RSocket is that this backpressure can be propagated across the whole network flow. 2 services, 3 services down, you can still have this propagated on and sent and adhered to by the whole flow. Cancellation, you have, most of the users nowadays have short memory spans, literally. We walk through on Facebook and we say, okay, hey, I like this video. Nah, I don't like this video anymore. I move on to the next one. When that happens, the client can simply say to the server, oh yeah, this request, cancel it. I don't want it anymore. I'm done with it. The server can then remove or release, cancel that request and release resources, and that make it available for the next string. Resumption. Now this is fun. We live in an era of, or age of constant internet connectivity, right? We have 3G, 4G, 5G. We have Wi-Fi, 5, 6. We have personal hotspots. Wherever we go, we get internet, and we can constantly use it. Till the moment that we go into a tunnel, or we come into a lift, or we go across multiple floors in the same building or in our house where the network switches, and then our connection drops. Resumption helps in setting up a acknowledgement mechanism between the server and the receiver. Let's say the server and the client and the server, they start off with 0 indexes packages. Yeah. The client said earlier, yeah, give me 2 packages. The server sends in 2 messages, 1 and 2. The client receives it, it acknowledges it, and then the network connection dropped. In the meanwhile, the server had already sent out package 3. But the client never received it because there was no network connection for him. When the network connection is established again, and the server tries to send in 4, the client says, hey, I'm at 2 already. I have received just 2. So you need to send me back 3 again. And this is the resumption that's really nicely enforced within RSocket itself. Transport layer flexibility. You can use RSocket with all the transport layers. Yeah? You can have WebSockets on one side. You can have UDP. You can have TCP. There's even talk of coming in on HTTP as well, as support for HTTP as well. You can have all of these applications across different across the whole landscape and built in different languages. It can be Java, it can be TypeScript, it can be Node.js, it can be C#, Go, anything. The libraries are coming in. It can, RSocket is, as a framework, supports multiple transport protocols, as I said. It is also supporting multiple languages. It supports multiple encoding formats like protobuf, JSON, custom binaries. Ultimately, RSocket works in terms of just binary messages, right? So it doesn't matter what you start off with. You always send it over the network as binary, you receive it over network as binary, and then you process it like that. My main motivation of doing this presentation is to sort of bring to you on why I see RSocket as a good alternative. And I would like to encourage you all to think about RSocket as a viable alternative to HTTP and REST, and use it in your applications, landscapes, and think where it could be. Based on for this, at Accenture, we are holding an RSocket coding marathon. Yeah? So think about a use case for you. That's a problem statement. You're seeing that, OK, this can be better solved with RSocket. You build a small POC or a solution for us. You bring it to us at the end of the day. We see what impresses us the most. And you get a drone and a Netgear or Wi-Fi mesh pack. We are all developers. I want to do a small coding session wherein I want to demonstrate a RSocket client and our RSocket server. And I want to do a demonstration over a fire and forget and a regular request response thing. But before I start doing that, can I answer any questions as of this moment? Yeah. Sorry.
Is it necessary for us to implement RSocket in client as well as server, or I can just say server uses RSocket because I want it to be scalable, but I want to keep client simple, or I have a limitation on a client and I will use normal communication?
You can put in a middle layer. That's what I'm trying to showcase as well. You can have a client which, or a small microservice which receives requests in HTTP, and then it sends it over to RSocket as an RSocket request. That works out as well. Yep, thank you. Any other questions that I can answer? Yeah.
Did you also look at gRPC, and what's the main differences? Or it sounds pretty similar.
I think the application Backpressure, that's something that's really RSocket brings to the table, and I don't think that's very well supported in gRPC at this moment. Okay, so let's do a coding session, right? It would be fun. So I have an RSocket server. I'll do a code walkthrough, and then I can explain to you what I have built, and then I can do a demonstration over the whole thing. Simple Spring Boot. Nothing very serious. As I said, Spring Boot. And the nice thing that you have is you have an RSocket dependency that comes in over here, bang. Yeah. I'm using Project Reactor so that I can work it through like this as well. If you know Java and controllers and stuff like that, it's very simple to understand it and start using RSocket automatically. So what I'm doing over here is I'm running a controller. I have marked it as controller 1. I'm exposing a route under current stock data. Yeah, it gets a stock data request, and again, it just throws back a mono, simple as that. Yeah, This is a stock repository. So it could be any backend implementation. It could be an API or you're using over here. It could be a database, anything that you think is good enough for you. The next thing that I wanted to see is this. You are running this on 7,000. Yeah, this is just there's a normal RSocket server that you run in. Nicely, I have put in the debug logging so that I can show you the payloads that go through as well. And while that starts off, I want to show this client. This is a REST controller, as I said, that I wanted to showcase. Yeah, it accepts. There's a get mapping. It gets this stock object, and then it uses this RSocket request here. Over here, it's a bean, as I said. It builds your RSocket request or the socket connection itself to the server. It has some options that I have had in there. What it does, it says, I'm going to use TCP to this domain and port, and I'm going to use these strategies. The strategies are for the encoders that come in that help in translate the payloads over the network. Yeah, so because they're all binary payloads, we have to use a Jackson or whatever encoder that you want to use or is more useful for you. And the data type, I'm just allowing all data types. So this controller has two endpoints. One is this. This is a simple request response. And I have a terminal. Okay. Let's do this. While this starts off, I have this. I have a nice postman here. It says a request response, right? So I'm making an API call here, send. What happens? So this is a client. It got a request. It made an API call to the server. As you see, the payload is completely binary. And it receives back this nice binary frame as well. You have the same thing on the server side. It receives a binary payload, and it sends back in this binary payload as well. And you have a response in here. Yeah, some stock and price or something of that sort. The fire and forget. This is what, as I said, this is what really interested me in the beginning. Yay, controller. Yeah. I am having this. I am exposing a new controller in over here. It says, the use case that I thought of is, you have an e-commerce website or something, and then somebody orders 1,000 articles of a single product. You want the website to be saying or logging something saying, hey, we have this suspicious behavior from somebody. Yeah, keep a note on it, and then you can use it for some tracking or something on those lines. That the client doesn't, the website or the client doesn't really care about it at this moment. So whenever this happens, I want to send an API call, a fire and forget API call to this endpoint, and then I want a small log line in here coming in through. That's it. Similarly, I have exposed an endpoint or a REST controller as well. And what it does is, it says route, and it says some object, that's it. So when I start running this, I see a REST and error in the postman because HTTP, it expects a response, but the client doesn't throw back any. So if you see here, you get this nice payload, which is a request. You see no response coming back through. Yeah. Similarly, in the server itself, you get a nice payload, and you see this log line, and that's it. You don't see anything else that comes in through. There's no response, so the network traffic itself is released up, or the network connection can be released up by the server and the client as well, and they can do on more important things. And that's pretty much what I wanted to showcase. So, can I have any other questions? It would be nice, yeah?
How does load balancing work? So if you have multiple RSocket servers,
Mm-hmm.
and you put it behind an Nginx, for example, does it keep the connection alive with one node and just sends request to that, or is it balanced?
It is balanced automatically, yeah. And the server at some stage, because of the backpressure and because there is no concept of a client, a traditional client and a server where the server cannot send events back to the client, and if the health of a server instance is going down or something, the server can simply say, hey, can you please stop sending me requests for some time? And then that's how you can have your resilience also implemented from the other side as well. Because the most of the resilience patterns that we think that we have right now for a Hystrix or resilience for J or something, they are reactive, right? So they have the situation where some API is going down. We see that it's going down for like 2 minutes, 3 minutes, and then you say, okay, we identify a pattern and then we react to it. Here, if the health of the server goes down, it can proactively say, I'm not doing so good. Help me out with low volume of requests. Maybe that would be helpful. That's a pretty nice one. Anything else? So the coding competition itself, yeah. Bring us your solution, and we want to see how it benefits you. What is most important, what is more interesting for you, and how you have thought of RSocket as a solution for your use case itself. If you really like it, we want to throw you back a gift. So it's good. Thank you very much. And have a nice day ahead.